In this video, we are going to see about linear combination, definition and some sums. Let V be a vector space and S be a non-empty subset of V. A vector V belonging to V is called a linear combination of vectors of S if there exists U1, U2, U3, etc. Un in S, alpha 1, alpha 2, etc. alpha n in F such that V equal to alpha 1 U1, alpha 2 U2, alpha 3 U3, etc. alpha n Un. So, a vector V, in V you will be able to write it as linear combination of these vectors U1, U2, etc. Un. So alphas are scalars, U1, U2, etc. Un are vectors of S. Now linear span. S is a non-empty subset of a vector space V. Then the set of all linear combinations of finite sets elements of S is called the linear span of S. All such linear combinations, if we collect, that we call it as the linear span of S. So this is just this one. A subset S of V generates V. The span of S is same as V. Now, here we are going to check whether 1 minus 2, 5, a vector from R cube is a linear combination of three vectors 1, 1, 1, 1, 2, 3, 2 minus 1, 1. So, let us consider the vector. Let us assume 1 minus 2, 5 to be a linear combination of the three vectors 1, 1, 1, another vector 1, 2, 3, and the third vector is 2 minus 1, 1. So I am assuming that we will be able to write 1 minus 2, 5 as a linear combination of these three vectors. A, B, C are all scalars. I am taking A, B, C from F. Now, whenever we write 1 minus 2, 5 equal to this way, it means 1 minus 2, 5 is equal to 1. We multiply all elements of 1, 1, 1 by A. So, actually it becomes A, and then next element is B, 2B, 3B. All elements they get multiplied by B, and all elements here they get multiplied by C. Now I am going to add for all the three vectors. So whenever we add vectors with three components, meaning is the first components they get added to give me the first component. So the first component is this. Second components we add. Now we go to the third component. So the given vector 1 minus 2, 5 is equal to this. Now two vectors of R cube are equal if component by component they are equal. I equate the first component with the first component, second component with the second, and the third with the third. So I get three different equations, A plus B plus 2C equal to 1. Let me call it as the first equation, A plus 2B minus C equal to minus 2. And then A plus 3B plus C equal to 5. So three equations with three unknowns A, B and C. Once we solve, we get the values of A, B and C. A is minus 6. B value is 3 and C value is 2. Therefore, we'll be able to write the vector, given vector 1, minus 2, 5 as minus 6 times the first vector 1, 1, 1, 3 times 1, 2, 3, and finally it is C times, that is 2 times 2 minus 1, 1. We are able to write one vector as linear combination of these three vectors. In this sum, we consider P3, polynomial of degree 3, less than or equal to 3. Okay, we are going to test whether 2x cubed minus 2x squared plus 12x minus 6 is a linear combination of x cubed minus 2x squared minus 5x minus 3 and the other vector 3x cubed minus 5x squared minus 4x minus 9. So let us consider, let us take 2x cubed minus 2x squared plus 12x minus 6 to be equal to linear combination of the given two vectors x cubed minus 2x squared minus 5x minus 3 and the other vector 3x cubed minus 5x squared minus 4x minus 9. So here what we are going to do is, let us multiply all these x cube, x square term, x term, constant term with a. Same pattern, let us multiply all the terms of the second vector, this vector by b. Here we multiply by a, in the second vector we are going to multiply by b, and then we equate the coefficients, equating like coefficients on both sides. So x cube coefficient, on the left hand side it is 2, on the right hand side it is a plus 3b. Let me call this as equation 1, and then x square coefficient minus 2, whereas here it is minus 2a minus 5b. X coefficient, left hand side 12, right hand side minus 5a minus 4b. Now finally it is the constants on both sides, minus 6 here, whereas it is minus 3a and minus 9b. So as we solve the two equations 1 and 2, solving 1 and 2, we get the value of a as minus 4, b value as 2, 3 and 4 are satisfied by a equal to minus 4 and b equal to 2. Therefore, we can write the vector 2x cubed minus 2x squared plus 12x minus 6 as minus 4 times the first vector. First vector is x cubed minus 2x squared minus 5x minus 3 plus b times, that is 2 times the second vector 3x cubed minus 5x squared minus minus 4x minus 9. So one vector we are able to write it as linear combination of the other two vectors. So here we are going to check whether the vector 2 minus 1 1 is in the linear span of S. S has two vectors 1 0 2 minus 1 1 1. Okay, so what we will try to do is we will take this vector as linear combination of two vectors of S. So A into this plus B into minus 1 1 1. Now let us equate the components. First component, when I equate, it is A here and it is minus B. So this is my first equation. Second component, minus 1 on the left hand side. Second side, A is into 0. So the first term becomes 0. So it's simply B. So I am able to get B equal to minus 1. Third component, 1 equal to 2A plus B. So let me solve these two. So first I am able to get B equal to minus 1. Now substitute in equation 1. So we are able to get A equal to 2 plus B, or it is 2 minus 1, which is 1. So A equal to 1, B equal to minus 1. So let us just check whether what happens to 3, whether equation 3 is getting satisfied with these two values, that is A and B. So when I substitute for A as 1 and B as minus 1, I am able to see that it gets satisfied. Equation 3 is satisfied by the values of A and B. Therefore, this linear combination, whatever we have written, is 2 minus 1 1 equal to 1 into 1 0 2 plus the value of B is minus 1, 1, 1. So the vector we are able to write as linear combination of this vector and the vector of S. Therefore, the vector given vector belongs to the linear span.